All right, it's week 2-6 coming up. I think it's the last full week before the break. This should be video. So I've got 2-6 coming up. I want to back up and do a couple things from week 2-5 first. But this should be video PS26ABlake. And I made a little bit of a change from what I told you last week. This is only my second year through this book. This chapter is way too much jammed in it with far too few examples, probably to avoid a copyright infringement lawsuit. But I told you that we were not going to do binary molecular compounds. We're just going to do it outside of this test separately. So the way this is organized is, this is learning to name and write chemical formulas for compounds. That can be hard. It can definitely be confusing. So to cut down on the confusion, we're doing this in separate pieces. We're going to do binary ionic compounds first. We did those in week 2-5. And in the future, I suppose I'll get better used to splitting this chapter up without things running into one another. We skipped a lot of those questions between 20 and 24 to put off for later, so we were just doing these last week. We're going to review those first today, and then I'll go on to ionic compounds that are made with polyatomic ions. So we're only doing 2 things on this test. After the test, we'll do a small unit on the molecular compounds, so you don't have to juggle 3 completely different ways of doing things on one test. If we do that, it'll be chaos and disaster, and I wouldn't blame you for not understanding it. If we get this down and then do this, that's manageable. So back from week 2-5, we did all of this, and if you were at home, you should have done all this stuff on paper, and if you want, transfer it to the worksheet. This worksheet, you didn't have to have it with you to do this. If you want to transfer it to that worksheet. And basically, we did, on page 571, one question from number 20, just potassium iodide, one question for 21, just Al2O3, should answer 22 and 23, and we'll put 24 off. And then you turn in all the work for the section, which includes that, and this worksheet stuff, and this practice stuff. You turn that in, I grade it, I give it back. Some of you are probably turning that in on Monday, December 14th. I'll look at it quick while you're looking at the video, give it back to you. So we're going to put off writing and naming binary compounds until after the test is done. It's harder, it's confusing to do them together. I don't want you, even if you get all done with your studying and you're ready to go, I'll have this on a video. Don't go into it until after you've taken the test. So now we're going to go on with, as soon as we do a little review with this. So here's our review of naming and writing chemical formulas for binary ionic compounds. We did this Friday, but I want to go back through it to review. If you react potassium with bromine. Potassium's here with an oxidation number of +1, giving 1 valence electron. Bromine is over here in this column with an oxidation number of 1, taking 1 electron. These electron numbers, valence electron numbers, match. So it's just KBr. And that is potassium, 2 names, brome, ide. If it's ide, it's binary, ionic. all of the naming we do has two names, a first name and a second name. You don't just list things. If you're going to do that, then just leave it blank and don't waste the pencil ink or pencil lead or ink from your marker. Now I wanted to mention one thing here. I can't remember. Oh, I know what it was. So on the test, we're taking things from this side, metal, and reacting it with this side, a non-metal. The stuff that we're putting off until after the test is binary and molecular compounds, and that's what you get when you react to non-metals up here, and they share and make covalent bonds in molecules. The naming system is different. We don't want to confuse that. Okay, Mg with O. Mg is over here in this column. It's magnesium. Oxidation number 2 positive gives 2 valence electrons away. O is over here. Oxygen. Oxidation number is 2 minus, which means it takes 2 electrons. This is a match. So I just have one of each. And that is Mg, O, because it's a match and I have one of each, and it is magnesium oxide. Okay, then we have Ca and N. I'll do the naming first on the last three if I remember right. Ca is here, it's calcium, nitrogen is here. So we have to end that second name with "ide." So it's calcium and nitrogen. Has to be calcium nitride. And you may have a little bit of question about exactly which letters to chop off and exactly which ones to leave. I'll be forgiving on that. Just try to chop a few off and add one on until it sounds right. Now, how many of each? Calcium's here, oxidation number 2 positive, giving 2 valence electrons away. Nitrogen is over here, oxidation number 3 minus, taking 3 electrons. These don't match. How do you make these match? Well, you'll have to move 6 electrons. If these are given 2 and these are taking 3, you'll have to move 6. That's what you call what? The least common multiple? So you need 3 2s and 2 3s. 3 2s. So if it's Ca2 positive, I need 3 of those, Ca3. If it's N3 minus, I need 2 of those, N2. Okay, Al with S. One back here. Aluminum is in this column, giving 3. Sulfur is in this column, taking 2. Not a match. But in the meantime, let's name it. We have aluminum, sulfide. And aluminum gives 3, sulfur takes 2. This is not a match. How do you make it a match? Well, we're going to have to move 6 valence electrons. 2 3s and 3 2s. So if you have Al3 positive, I need 2 of those. If it's S2 minus, I need 3 of those to make aluminum sulfide. And the last one, I have barium and iodine, so it must be barium iodide. So let's go look at the numbers for that one. Barium is here giving 2, iodine oxidation number 2 positive. Iodine's oxidation number is 1 minus because it takes 1 valence electron. These don't match. I need another iodine. So it's Bai2. Ba2. Okay, and all of that stuff we already did. I know we did, but I'm trying to drive this home because the next thing we do is going to be different, and then you're going to be confused. If you don't know this, cold turkey. There you go. So this is what we have. Let's go on then. So we're going to do binary covalent after the test. Now we're going to do ones with polyatomic ions in them. And there's a table on page 569 I have ready to go. I think I'm done with this. I'm going to say I'm done with it. Okay, so here's our handy dandy table again. You need to use that a lot. You'll have that on the next test. So here's the same thing. Now we are going to move on to ionic compounds. There's still something giving, there's still something taking, there's still a positive, there's still a negative. But they have polyatomic ions. So what is a polyatomic ion? We already talked about this, so I can move on. It is a positively or negatively charged group of atoms. Really, it's kind of like a molecule with a charge. When you are naming these compounds, there's still two names. There's two names on everything we're doing. The ammonium ion is the only one that's positive. The positive name is first, the negative name goes second. That's not new, that's the same thing. The difference is we don't end these names in "ide." We just end with the name of the polyatomic ion. Are there exceptions? Yes. But you aren't going to see them this year. There are dozens of polyatomic ions, maybe hundreds. Chemistry class, I will have you use about 2 dozen. That's next year. These are the ones you're using. You only have 1, 2, 3, 4, 5, 6, 7, 8. You don't have to memorize them. This year they're in the periodic table. Notice I lied to you. I said these names don't end in "ide." There is one that's on this table, hydroxide, and I'm going to avoid it, so you don't have to worry about that. For you, if it ends in "ide," it's binary. So I'm not going to give you one's oxide on the test or quizzes. Hydroxide. So from the top of this worksheet that you should have done on your paper, by the time you watch this, you will have a hard copy of it. Let's do the not binary ones. The binary ones were sodium chloride, magnesium fluoride, boron oxide, and strontium bromide. So it was this one, this one, this one, and this one. What are the names of these? Well, what is the polyatomic ion part? If you look back here, you might want to pause and do this. On this table, here are the polyatomic ions parts. You have a carbonate, a phosphate, a nitrate, a sulfate, and an ammonium. So you have this one, sulfate, phosphate, and a nitrate. Is that what I had 4 of them? Nitrate, sulfate, ammonium, and a carbonate. And this one. There's 5. Okay, so let's name these. Name's a little different because you're not going to end the name in "ide." Except for hydroxide, you don't have to do that one. This one is sodium carbonate, potassium phosphate, ammonium chloride, because it ends chlorine, you have to end with "ide." Now that's not binary, but it ends in "ide." Yeah, I know. But that's because the second one came from the periodic table. So I guess that's really the rule. Magnesium sulfate, calcium nitrate. What are some of these things used for? Sodium carbonate is baking, something in baking powder. It's washing soda. It's used for a number of things. This could be used as a fertilizer for crops. If you need phosphorus and potassium in your crop fertilizer, you put some of that in it. Ammonium chloride Probably not particularly useful. This one is Epsom salts, if you use that. You probably wouldn't use that for any particular thing. Now, let's do the opposite. Let's write the chemical formulas. And this, again, comes from the worksheet here. So I guess the bad thing is if I gold turned that in, I'd probably still have it here. So you need to do these on your paper, gold. Okay, on the worksheet, the bottom 4 out of those 8 we already did. These are the top 4, and they are calcium carbonate, sodium acetate, ammonium sulfate, and phosphate. So we got acetate, carbonate, sulfate, and phosphate. We are going to use acetate, sulfate, phosphate, and I think I said carbonate. So use them off that table out of your book. This is on page 569, table 4. Okay, so the name of this one is sodium carbonate. I think I did the naming once. Yeah, now we got to write the chemical formulas. Calcium carbonate. Okay, this is a little trickier because you can't leave charges in there, but calcium is in the 2 positive column. It's in the alkaline earth metals, and carbonate is CO3 2 minus. Let me show you. So we got to count these on our fingers again. Carbonate 2 minus. Oh, here, I've got this on my screen. Whoops. I've got this on my screensaver. Okay, calcium is here, 2 positive. So how do you do that one? It is gives 2, took 2, it's a match, CaCO3. How about sodium acetate? Okay, well if we back up a few pages, acetate is C2H3O2 minus. C2H3O2 minus. If you look on the paper, sodium is back here, 1 positive. So it's Na positive. Now you don't leave this stuff in your answer. Here's your answer. So, but to figure it out, you might want to write them down and then scratch them out. Sodium gives 1, acetate took 1. This is a match. So it's just NaC2H3O2. What about ammonium sulfate? Okay, I'm going to erase these because they're in the answers. Ammonium, and oh, that's got 2 polyatomic ions. If you go back here, sulfate is SO4 2 minus, and ammonium is NH4 plus. So ammonium is NH4 plus, sulfate is SO4 2 minus. Uh-oh, we have 1, gives 1, took 2. This doesn't match. How do we make these match? I need another ammonium. I need 2 of them. Well, how do I show that? If there is more than 1 polyatomic in a chemical formula, you use a set of parentheses to show that the whole thing gets doubled or tripled. So this one is NH4, and I need 2 of them, and an SO4. And the last one is potassium phosphate. Potassium, whoops, is here, right under, a couple spots under lithium, giving 1. So it's K positive. Phosphate is PO4 3 minus. So going back here, phosphate is right there, PO4 3 minus. So I have Gibbs 1, took 3. Uh-oh, not a match. How do I fix that? I need more potassium. In fact, I need 3 potassium, so it's K3PO4. And you probably have questions, which is good. Ask them. So these are your answers on your worksheet. And then go back to the homework, and I'm gonna cut this video off here and do the homework. I'm gonna finish the 20 to 24, finish more of those questions on the next video. The next video is PS26ABlake.